Hi everyone, welcome back to my channel. My name is Satyaam Raha. Let's get going with the series of deep learning. So in the last video, we saw how to find out the derivatives, and we actually did the entire process for a single neural network, right? Single neural network. So that was just for a dummy so that you could understand the concept. Now in this video, we will do the entire process using a neural network, that is an MLP, okay, which will have more than one layer, okay, and will have multiple neurons in the neural network. So it will be a bit complex. So please do not just watch this video. You write the entire thing, otherwise it will be very confusing for you. There are two prerequisites for this video. So before you watch this video, please make sure you have already watched the notation video. Okay, I think it was second or third in this series. So please watch that notation video. And the second prerequisite is you have already understood the entire process for a single neural model, right? Then only you will be able to understand this particular thing. Otherwise it will be entirely confusing for you. So let's start. So I hope my screen is clear. So here we will be training a MLP, means multi-layer perceptron, okay, which has here see input layer, hidden layer 1, hidden layer 2, and the output layer. Okay, so here we have three functions in the hidden layer 1. We have two functions in hidden layer 2. That means we have two neurons here, three neurons here, and this is the final neuron. So everything else is same, and I have not written here all the weight notations because it will be very messy and very complex to understand. Okay, so I have written only few things. Okay, like O11 means the output of the function f11. Fine, O11 is getting transmitted from f11 to both these edges, right? Here O12 same output is being transmitted from f12 to these two paths, right? Here you already remember the notation, I guess. So W111 means this one is nothing but the layer, right? The present layer. This one is nothing but the input from where it is coming. Okay, it is a first input, that is a one. The second one is nothing but to which function it is going. Okay, here also see layer number 2, this is layer number 2, right? So here the superscript is 2. This first one is nothing but from which neuron it is coming, from neuron 1. Okay, and this one is for the next neuron. Here also it is the first neuron in this layer. Similarly here you can see this is the third layer, W3, and see this 2 means in the previous layer what is the number of neuron, which number or which neuron from this data is coming. It is from the second neuron, that is why 2. This is the first neuron, this is the second neuron in this layer, so 2. And it is going to which neuron in the next layer? It is going to the first neuron, so to 1. Okay, I hope this is clear, and if you have any doubts, please visit the notation video first. Now without wasting much time, I'll just go into the problem. Here the problem is regression, and obviously we are using the squared loss here. Dataset is xi, yi, where xi is a 4-dimensional vector and yi is a scalar, right? Okay, now let us see the next step. So the steps are same as the earlier one. Okay, the first step is what is the loss? The loss here is nothing but I equals to 1 to n yi minus yi hat whole square, plus there is a regularization term just to deal with the overfit and underfit. And just to recap, L2 regularization or L1 regularization is present. So L2 regularization is nothing but summation of, okay, I j k. Here you see w k I j. Here we should write like this. This entire thing whole square. This is L2 regularizer. L1 regularizer is nothing but similarly I j k over all the I j k. Okay, here you just need to take the absolute value. Here it will be k. Okay, so this is L1 and L2 regularization. Okay, so I think I have already explained these concepts in logistic regression video in the machine learning playlist. If I haven't, then I'll just make a video and add it to the playlist. So this is regularization, and right now you no need to go very deep. Just understand regularization is nothing but it is used to control overfitting and underfitting. Okay, this is my loss. This is my loss function. Okay, and if Li is for a single point, then for I should write here I. Okay, then the entire loss is nothing but, okay, and this is summation, right? So I shouldn't write it here, right? This. Okay, so it is nothing but I can write it here like this, L of I plus regularization. Okay, where Li is nothing but loss over a single point, yi minus yi hat. Simple. Okay, so this is the definition of loss here. Number 2 was optimization. What is the optimization formulation? It is nothing but we have to minimize L over W, right? What we can change? We can see X and Y are constants, right? We cannot change it. It is from the data set. What we can change? We can change only W. So we need to find the optimal W, and we need to minimize the loss L. Okay, what do I mean by that? We can write it like this: minimize W k I j summation I equals to 1 to n, means over all the points yi minus yi hat whole square plus regularization, right? This is my optimization formulation. I need to minimize this. Okay, now the third step is nothing but SGD or GD, gradient descent, or stochastic gradient descent. What are the steps here? The first step is initialize weight vector, right? So let us say we do it randomly. There are many ways to initialize the weight, but let us say we want to do it randomly. Okay, random initialization. So what do I mean by that? Here are some W's, right? Here are all these edges will have W's. So these values, what are the initial value for this? So just give random values to them. Okay, so this is random initialization of the weights. Number B is nothing but the update rule, which is W I j a new is equal to W I j k old minus eta times dou L by dou W k I j, right? This is very simple. We have already done it earlier for a single neuron. Here we are doing it for many neurons, multi-layer perceptron, right? So it is very similar. It is very similar. Here again the concept of learning rate, I'll explain it for in a different video for SGD, where I'll show you how SGD works. Okay, diagrammatically how it works. So right now just understand, let us initialize learning rate. This learning rate is nothing but a hyperparameter, so let us give it some random value right now. Okay, this is how the update rule is actually happening, right? So these 3 steps. What is the next step? The next step is nothing but the updation, right? Or how to find out the derivatives, right? So that is my number C. Okay, perform updates till convergence. It is as simple as that. Convergence means till the weights do not change much. So let's update. How to do it? I'll take a different color. Okay, I'll just very thin. Okay, so you see, let me look at the picture. See here, loss with respect to what? Let us find this loss with respect to this particular weight. This is the nearest weight, right? We'll go step by step. First find out this layer, these weights, next find out these weights, then we'll find out these weights. Okay, so L with respect to this W311, this weight W311. Okay, so bear with me. W311, this will be some value, and next another one is in the same layer we have W321, right? Sorry, W321. So how can we find this value? So it is nothing but dou L. See, the same concept. This L is dependent on O31. Let's take in the last example we use the function names, right? Here let us use the output O31. Same thing, right? Ultimately same thing. It will be much easier to understand if we use this notation. So this loss is dependent on the output 31, and this output 31 in return is dependent on this particular weight. Yes, so O31. So just use the chain rule. Output 31 multiplied by O31 is dependent on what? Weight 3, this one. Simple. Similarly here you see, this is dependent on what? See here, this loss is dependent on this weight, sorry, this output, and this output is dependent on this particular thing. Yes, so W321. So O31 multiplied by O31 W321. This is simple chain rule. I hope this is very clear. This is for the first, this is for the third layer, right? For this layer, we found out the weights. These weights. This is the layer 2. Okay. Now let us find for this W211. Okay, let me do it in a different page. W211, I guess. W211. Okay. So see, this loss is dependent on O31 first. Then this particular O31 is dependent on O21. This O21 is dependent on this weight, isn't it? So the chain is loss with respect to O31, O31 with respect to O21, O21 with respect to this weight. It is very, very simple. Okay. Let's write it. So it will be loss with respect to O31 multiplied by O31 with respect to O21 and O21 with respect to this particular weight W211. Okay, so since there are 3 values here in the chain, so we have to multiply three components. Similarly, we can find out for the other values. Let's say W2, let's take another one just for an example. Let's say, what is this value? This is nothing but W2. It's coming from 3 and going to 2. So 3, 2, right? So here you can see this loss is dependent on O31. O31 is dependent on, here you see it is dependent on O22. O22 is dependent on this, right? So W232. W232. How can we write it? We can write it as it depends on O31. O31 in return depends on O22, right? O22, and O22 depends on this particular weight. Sorry, I have to just go back and forth, but you can write in a single page and you can refer it, right? So this is how you can find all the weights in this particular layer. This particular layer, you can find out all the weights likewise. When it comes to this one, this is a bit tricky. Okay, I'll show an example. Let's say W111. Okay, it is a bit tricky. I'll do it in a new page. So loss with respect to W111 in the first layer. So how can you write it? See one thing. See, before that I'll show you a principle of chain rule. That is, if this is the path, let's say x is going to certain function f of x, okay, then this f of x is going to certain function h of fx and g of x, let us suppose, and here we have something called as g of x. That means this function is dependent on both of these. Okay, this is different from the earlier example. Okay, this is the situation. If see, this h of fx is dependent on f of x as well as g of x, right? So in that case, if I have to find the derivative of this, derivative of h with respect to derivative of x, what we should write? We should write derivative of h with respect to derivative of f multiplied by derivative of f like this. So this path, derivative of x plus, this is one path, right? This is one path. The next path is derivative of h with respect to derivative of g multiplied by derivative of g with respect to derivative of x. Okay, this is a chain rule. Okay, this is another form of chain rule. So if this is the situation, this should be the derivative. Now see, for this particular weight, see the similarity here. For this particular weight, you see here it is coming like this, that is fine. Up to here it is fine, but here you see there is another path. Can you see the difference? I'll mark it, maybe I'll try to highlight it. See, this is the path now. From here, this is one path. Also, there is another path from here till this. Can you see? This is f of x and this is g of x and this is say x. That means this particular loss is actually coming from two paths like this, from here, from here. So we should use that chain rule formula here in order to solve it, right? So let's solve it. I hope you have drawn it somewhere and refer to the picture. Okay, so here we'll write it like this. See, the first step is simple. So it is dependent on O31, yes or no? It is directly dependent on here. From here, no problem. It is dependent on O31. From here, it gets divided, right? So we can write it like this. O31 multiplied by O31 with W111, right? Now you see O31. Let's keep it. Let's take it as common. We need to find out this one, right? And this one will follow this rule. Okay, what it will be? It will be, check it here. Check it here. See, O31, here O31 with respect to O21, O21 with respect to this O11, O11 with respect to W11, right? Plus O31 with respect to O22, O22 with respect to O11, O11 with respect to W11. It's very simple, right? It's very simple. I'll write it down. See, so this one, O31 with respect to O21, just visualize the path. O21 with respect to O11 multiplied by O11 with respect to this weight W1, sorry, one, right? This is the first thing. Okay, I'll just do a divider. Okay, this one plus we have another path. What is the another path? Another path is nothing but derivative of O31 with respect to O22, isn't it? Just check here. O31 with respect to O22, O22 with respect to O11, O22 with respect to O21, sorry, 11, and O11 with respect to W111, right? So this is how you can find out the weights here. You can find out these derivatives. Okay, I know this is a bit complex and it is taking a lot of time, but with practice, if you understand it, it is very easy to perform. Okay, see, just visualize it. Okay, just visualize it. This is a path and here also we have a path. This is the difference. Here we did not, for this weight we did not have this problem, because see, how did we reach this weight? We reached this weight only from this path. If you think from this path, no, we could not reach this weight, right? But for this weight, we are reaching from this path as well as from this path. That is why we need to do this special case. For this one also, let's say 4-3, what will happen? One path is from here directly. So it will be L with respect to O31, O31 with respect to O22, O22 with respect to O13, O13 with respect to W43, 143. Number one. Number two will be O31 with respect to O21, O21 with respect to O13, and O13 with respect to this, because this is the path this particular weight is following. Likewise. Okay, so I hope the concept is clear, right? So I'll leave it on you, because until and unless you write it on a copy, it will not be clear, to be very frank. Okay, you can find out all the weights similarly, right? It is very easy. Just if you have understood it, you can do it, right? So that's it for this video. Okay, and in the next video I will show you a concept called memoization, and then back propagation. Okay, so these are the basic concepts, but whatever I have already explained till now, this is the crux of deep learning training. Okay, if you could understand this, you have understood like the main thing or the base thing of deep learning. This is how the entire training process behind the scene happens. The only thing that is left is to visualize how the gradient descent works. Okay, so I'll make a different video for that, but till now whatever I have explained, please write it on a paper, write it on a copy, and do it on your own. Okay, do not watch this video while writing, just do it on your own, then you can cross check. That way it will be very easy to understand, right? So I hope you like this video. Thank you for watching. See you in the next video.